is some more integration by parts. This one is really gonna suck because it requires integration by parts 3 times. So if you ever have something where you have x to a power times sine or cosine or e to the x, the power on x actually tells you how many times you're gonna have to do integration by parts. So I'm showing you how much this one sucks because then I'm gonna show you how much nicer it is if we use the tabular method. So first step, u equals x cubed, right? Again, using late, LA, algebra, u is the algebra term, x cubed. Trig, right? dv, so we didn't get the trig because we stopped it. So my dv is sine of x dx. Du is 3x squared. Dx, v is the antiderivative sign is negative cosine of x. Okay, so this ends up equaling, and I'm gonna try and keep this relatively kind of separate because I have to do this 2 more times. So I'm gonna get the uv, so x cubed times negative cosine x minus the integral of v du, which is negative cosine times 3x squared dx. And people differ on how they like to do this. I personally prefer to pull out any kind of constant multiples. So I would rewrite this as negative x cubed cosine x plus 3 times the integral of x squared cosine of x dx. Okay, and then I'm going to do a new integration by parts for this integral. So for that integral there, maybe I'll use a different color. The colors are good. So that integral there, I'm going to let u equal x squared. This pen is not great though. Try a different pen. So u is x squared, dv is the rest. That's a better pen. That's the one I was looking for. Du is 2x dx. And v is equal to the antiderivative cosine is sine of x. So then the uv minus the integral of v du is going to go in for the integral here. So this is going to end up equaling, we still have this part here, plus 3 times all of whatever this is, which is the uv. So right, it's 3 times all of the uv minus v du. uv is x squared times sine of x minus the integral of v du is, let's just bring the 2 out in front. So it would be sine of x times 2x dx. Let's say there's the 2x times sine of x dx. Right, it's still the same as minus 2x dx sine of x. I just rewrote it. Okay, so now for this integral here, it's getting a little crazy. So for this integral, I'm again going to do a new integration by parts. So I'm going to let u equal x, dv is the rest, which is sine of x, dx, don't forget the dx, that's important. Du is equal to 1 dx, and v is the antiderivative sign, which is negative cosine of x. Okay, I might actually distribute this 3 before I do this part here. So I've got negative x cubed cosine of x plus 3 times x squared times sine of x plus 3 times negative 2 times the integral of x sine of x. So now I'm doing this, and that's just the whole new uv minus the integral of v du. Whew, okay, so it's negative x cubed cosine of x plus 3x squared sine of x minus 6 times integral of x sine of x is uv minus the integral of v du. So it's x times negative cosine of x minus the integral of negative cosine x dx. Minus and minus is a plus. The integral of cosine is sine. Sorry, I just want to try and fit this all here. So I end up with negative x cubed cosine of x plus 3x squared sine of x minus 6 times x times negative cosine is positive 6x cosine x. And negative 6 times sine is minus 6 sine of x plus c. What a giant pain in the butt. Okay, let me show you how to make it way easier. This is called the tabular method. So u is the u thing. And then you write all the derivatives. of u. So the derivatives of x cubed are 3x squared, 6x, 6, and 0. If you don't get to 0, it means you shouldn't be using tabular. The only choice for you should ever be, when using tabular, is x to a positive integer power, like 3 or 7 or 19. dv, I'm still making the same choice, it's sine of x, but then here I'm not writing the derivatives, I'm writing the anti-derivatives. So the antiderivative of sine of x is negative cosine of x. The antiderivative of negative cosine is negative sine of x. The antiderivative of negative sine of x is positive cosine of x. And the antiderivative of cosine is sine. By the way, the only reason tabular really works for either sine or cosine or e to the x is because their antiderivatives all kind of don't get terribly complicated. Like the integral of e to the x is just e to the x. The integral of sine and cosine just cycle through sine, negative cosine, etc. So that's why these are the only ones. So here's, oh, and then we have to do one more thing. I believe this is my good red pen. So these, that's not my good, this is my trash red pen, sorry. So every other one, so this is, I don't want to say it's positive, but it's plus this times this. And then minus this times this. And then plus this times this. And then minus, and it just keeps alternating. So it's plus this times this, minus this times this, plus this times this, minus this times this, etc., 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 etc. Okay, so then my integral is equal to plus x cubed times negative cosine x minus 3x squared times negative sine of x plus 6x times cosine x minus 6 times sine of x. I feel like I might have missed the last sign there. Plus c. So I end up with negative x cubed cosine of x plus 3x squared sine of x plus 6x cosine of x minus 6 sine of x plus c. Let's compare that. It should be the same, but I feel like I made a mistake. Nope, I didn't. Exactly the same. So way, way, way less work to do it using the tabular method. So tabular method works for anything like integral of x to the n times e to the x, integral of x to the n times sine of x, integral of x to the n times cosine of x. Those are the only 3 types of integrals where you can use the tabular method for repeated integration reports.